so okay, so see, there are a bunch of tools and a bunch of services that AWS offers, which provides management and governance, right? Because that's going to be very, very important. Right? We saw one tool yesterday, where we used to we used it to monitor the AWS resources like EC2 and S3 and so on and so forth, right? So similarly, there are a bunch of other tools that are available. You're not expected to kind of know each and every one of them. It's okay. I mean, if because AWS portfolio of services and AWS ecosystem of services is quite vast, and it's not possible to kind of know each and every one of them and have a hands-on experience with each and every one of them, which is absolutely fine. That you don't need to learn each and every one of them because it's not possible. Even I don't know honestly every other service that is available. Um, but what you should know is you should know what service is used for what purpose. Correct. So that's important, right? I mean, you should at a high level know that okay. So if I were to monitor my resources and alert and act on that, I should use CloudWatch. And if I have to ensure compliance of my resources, I should use config, right? If I have to audit the activities that are happening in my AWS account, I have to use CloudTrail. Okay. So similarly, there are a bunch of other services that will provide governance controls and provide management, uh, ease of management to your users. So let's look at that. Control Tower is basically a service, which allows you to. Okay, so usually when customers or usually when enterprises use AWS, it's not going to be a single account, single VPC, right? They will have multiple accounts and multiple VPCs, which will help segregate the various different environments. Like they want to segregate probably the development environment, testing environment, or QA environment with the production. They want to keep the production completely isolated so that nobody by mistake fiddles around with the production environment, and they maintain some sort of a logical segregation and physical segregation between production environment and non-production environments, right? So that way, it's usually a strategy which comprises of multiple VPCs and multiple uh, accounts. And also what happens is, say for example, you have single VPC where you put all your resources in, right? Such as your development environments, your production environments, QA testing, your lab, R&D environments. Everything is in one single VPC. It becomes very difficult to manage that. It's not that easy to manage, right? It gets quite cumbersome from an operations perspective, because you want to make some changes at a VPC level, say on the dev environment, that's going to impact all the other environments, including your production live systems. Correct. So, and also if you see, when you're when a hacker gets hold of your dev environment or the dev VPC, he can easily break into the production systems, and he'll be able to take away the data, and your blast radius is very, very large. Okay. Whereas if you see, if you take a approach where you're having multiple different accounts with well-defined segregation of roles and responsibilities with various different users, because usually your dev team won't have access to the production environments, right? Only a production support team will have access to the production environments, and they'll have enough processes to govern that. And many changes that are made is done through a change control. It's done through a change request, which gets approved by the change approval board, right? And so it's not going to be that easy to kind of make changes to production environment, because it's live system, right? Imagine Amazon.in is there, right, which is a production system. So now, if any loose changes are made in that, which is impacting the entire service, look at the business impact that Amazon will have, right? So that way, it will be well governed and it will be well managed, right? So that's the reason why you will have a multi-account, multi-VPC strategy, which will reduce the blast radius. When I say blast radius of any attack surface is very, very limited. If somebody gets into an EC2 instance in the dev environment, maximum he can be within the dev VPC. He can't go outside of that VPC. But if you put everything in one single VPC, if you put prod, dev, and everything in one single VPC, then he can easily get access to the prod VPC as well. Okay, so that's where AWS Control Tower is an easy way to set up and govern secure multi-cloud, multi-account AWS environment. Sorry, not multi-cloud, multi-account, multi-VPC AWS environment. AWS organizations is another service that feature that enables you to define organizations within your AWS account, where you have a master account, a multi-account strategy, and you have a master account. Within that master account, you can create an organizational unit. Like, for example, I'm a large organization. I've got multiple departments in it, like sales department, finance department, HR, right? R&D, product incubation, and so on and so forth, right? Core legacy departments and so on and so forth, right? So you can create you can create these multiple organization units and departments within that, and you can have accounts specific to each department. So that way, each department has got their own accounts and they're managed centrally through the organizations. That way, at an organizational level, you can apply all the policies to all the accounts, such as password policies or such as public blocking public S3 access, right? If you want to block public S3 access at an organizational level, because that's your policy, right? Then you can actually centrally govern that through the AWS organizations. Skip the well architected tool. That's basically a tool that AWS provides to run to check whether your application or your infrastructure is architected properly or not. Whether is it following the best practices or not? That is what it does. License manager is again another service which is used to manage the licenses. Like, for example, when you have third-party COTS licenses, commercial off-the-shelf licenses from Microsoft, from Oracle, or from other COTS products, COTS vendors, you can use this license manager to govern the licenses, because many times what happens is when organizations buy licenses, they tend to overshoot the usage of those licenses and get into a non-compliance, right? So then the software vendor comes and imposes a heavy penalty on the organization for overusing the license. So from that perspective, AWS License Manager is integrated with all the AWS services. So you can keep a tab of how many licenses you're using and how many are left out, and are you overshooting, or are you in a safe zone. Then comes the other services such as Service Catalog, CloudFormation. CloudFormation we spoke about. Service Catalog is a place where you build a service catalog and then you expose it to the end users. So end users can just use the service catalog to provision services by themselves. They don't need IT administrators. Ops work Ops works as it's basically a AWS version of Chef and Puppet, right? So basically, if you see, I don't know how many of you know what Chef is. Chef is a very, very famous and okay. So Chef is basically a it's a automation platform that enables you to automate deployment of software, deployment of infrastructure components and everything. Okay, Chef is quite useful, and if any of you would want to pursue a DevOps career, it is important for you to learn Chef. You have to definitely know what Chef is. Okay, it's an automation platform primarily. Okay, so Chef and Puppet also. Yeah, make infrastructure actionable, scalable, and intelligent. Yeah, this is like Puppet. All right. So let's just go back. So it's marketplace is there, right? And then you have your CloudWatch. We spoke about CloudWatch. CloudTrail, we saw CloudTrail. Okay, config is a service which enables you to keep your configurations at a baseline level, right? So basically, what configurations, right? So for example, I have a S3 bucket, okay, and my S3 bucket, I want to ensure that all the time, the public block public access is enabled. Okay, I don't want my S3 bucket to go private public. Okay, I want to always keep my S3 bucket public. So by mistake, some administrator goes to that S3 bucket and makes it public. Okay, immediately what you can do is you can detect it using config, where config can maintain the baseline configurations of every other service or resource within AWS, and it can immediately detect that somebody has made it uh, public. And what it can do is it can notify, and it can also remediate that through an automation, where it can say that it can trigger a Lambda function that will go and or an automation script that can go and modify the S3 bucket to back to its private through the bucket policy. Okay, that is what config does. In fact, config is a very, very important service. You should also learn config. We'll just see a short video about config.
AWS is constantly innovating to bring its customers the best choices in cloud services, resources, and software. Yet with so many custom options to choose from, it can be challenging to make sure your resource configurations are efficient, secure, and complying with best practices. Introducing AWS Config, an easy-to-use service where you can assess, audit, and evaluate the configurations for all your AWS resources. With AWS Config, you can define the policies and guidelines for your AWS environment and receive notifications whenever a resource's configuration deviates from these rules. And if any non-compliant resources are discovered, Config provides automatic remediation, so you can get back to compliant and secure status as soon as possible. This enables you to monitor security weaknesses and track whether or not your resource configurations comply with government regulations and best practices across all regions. You can also evaluate your existing configurations against desired ones, as well as continuously track any changes you make against your other AWS resources in order to better analyze efficiency and performance. AWS Config also features dashboard displays on your config console, allowing you to view your compliance status and resource inventory at a glance. You can even integrate Config with other AWS services, so you can seamlessly track activity logs and specific events within your account. AWS Config empowers you to keep your configurations secure and up to date with the most efficient AWS solutions. Sign up and get started today.
Okay, all right. So that's where config is, right? So config is a very, very important service. I would recommend all of you to kind of try out config. But again, config is a paid service. Let me see if there is a free tier available. I don't think config has a free tier. So, but yeah, you can just watch some YouTube videos where you can just configure a rule on the on a few configuration items, right? And then you can uh, there are several videos available on the YouTube. Okay, all right. Systems manager. Systems manager is again another service. So now with systems manager, you can get operational insights and take actions on AWS resources. It's like not monitoring. It is not monitoring, but systems manager is where you can get a centralized access, a centralized location from where you can gain access to your AWS resources, and you can manage their operational health, right? Such as, like, say, patches, right? I mean, where all of us have seen that our Windows or Linux or Mac receives updates every month, correct? Or mobile phones also receive updates every month, correct? You have to install those updates so that you stay up to date with respect to any issues or any security bugs or any security vulnerabilities that are identified. So now systems manager is again a centralized service, which can provide operational insights and it can take actions on AWS resources. Okay, where it can give you visibility and control of your infrastructure on AWS. It provides a unified user interface so that you can view your operational data from multiple AWS services and allows you to automate operational tasks. Okay, so now Systems Manager, let's look at a simple video of Systems Manager.
As an IT or DevOps professional, you need to manage and operate securely across your entire infrastructure, whether you are in the cloud, on-premises, or a hybrid of both. Instead of working with multiple tools that were not built for cloud scale with complex licensing for different environments, you need a secure and scalable solution that gives the visibility and control you can trust. Introducing AWS Systems Manager. With AWS Systems Manager, you can group, view, and act on resources, operating safely across your entire infrastructure. Group more than 100 resource types into application, business unit, environment, or any category that makes sense. View instance information, such as operating systems patch levels and installed software, and see how that complies with your desired state. Act to associate a configuration with resources and let us tell you when they do not match. Distribute software versions safely across your instances. Increase your security posture while executing a command or script on your instances and when interacting directly with them. Patch your instances on a schedule to keep them compliant. Automate workflows using APIs to create powerful runbooks. And reduce errors by securely storing your application configuration parameters in a centralized service. AWS Systems Manager provides the tools you can trust to safely manage and operate your entire infrastructure. Get started using AWS Systems Manager today.
Yeah, so that's basically the Systems Manager. I'll give you one more example. When you have, say, 5 EC2 instances, it's easy to manage those 5 EC2 instances. It's easy to patch them. It's easy to deploy softwares on it. But imagine that 5 becomes 5,000. Correct? You need a scalable way. You can't log into each and every EC2 instance to make some changes, right? Or for example, how many of you know about the Heartbleed vulnerability that came a few years back? There was a vulnerability called Heartbleed. How many of you heard about it? Okay, it was quite a serious threat. Okay, I read about it. I mean, it's quite interesting. Okay, I go to heartbleed.com. You can read about it, and you'll hear a lot of stories about Heartbleed. Okay, so where Heartbleed was a vulnerability with the OpenSSL module, right, which provides the cryptographic operations to your operating system, to your softwares, to your applications. Okay, the whole SSL TLS encryptions, right, which is used for encrypting the data, that is dependent on the OpenSSL cryptographic software library. Okay, so that popular OpenSSL library had a bug in it, which was exploited. But before it could turn into a widespread, because if you see, pretty much everything that we do on the internet uses OpenSSL. Because the moment you see it's a HTTPS connection, the moment you see that you're using a SSL certificate or a TLS protocol, it means that you're using OpenSSL. Okay, almost pretty much every other software, every other operating system has compatibility with OpenSSL, because that's a common library which is used across the board by software developers, by administrators, by product developers to provide a cryptographic encryption to your application, to your data. Right? Pretty much everything that you see uses that OpenSSL. So now imagine when there is a bug with the OpenSSL library, and hackers figured it out. and they exploit that bug, and then they take sensitive data. You open any website, right? You open icicibank.com. It uses SSL, right? You open bankofamerica.com, that uses SSL. Okay, anything. You take any website, any financial website, or anything for that matter, it uses SSL to decrypt and encrypt the data, right? At the end of the day, pretty much it uses an open SSL. Okay, so now from that perspective, it was a vulnerability that came into light in April 2014, about 6 years back. Okay, so where the attackers could actually exploit a bug in the OpenSSL library to gather sensitive information. Okay, and like major sites reported it to be a major concern, like Yahoo and all. Okay, uh, yeah. So now you can read more about this, right? And in fact, it affected 17% of all SSL servers. Okay, and it was a crisis situation at that point in time, right? So then what happened was there was a patch which was made to the OpenSSL library. Okay, in fact, yeah. So this was the mem copy was the mistake that was done by the developer who wrote this piece of code. Yeah, and it's open source software, right? OpenSSL, right? So basically, if you see, it was fixed, right? So the code was fixed, and OpenSSL had given a patch, a hot fix, immediate hot fix that had to be deployed in millions of servers across the world. That heartbleed, because of this heartbleed, millions of servers, millions of operating systems servers were, or devices were, because it's not just about servers, right? Even you take devices like your firewall, routers, proxy devices, switches, everything has an operating system in it, some sort of an operating system, embedded operating system like a Linux in it, correct? So now all of those also would be using OpenSSL library, correct? So now everything had to be patched. Okay, every other small device which was using OpenSSL library had to be patched, right? And in such case, imagine, you have to, you are the AWS systems administrator, right? And you are managing like about 5,000 EC2 instances in your organization, 5,000 Linux EC2 instances, and suddenly you get this heartbleed kind of a vulnerability, and you get a patch for it, hot fix. It has to be immediately deployed because your customers would be behind you, asking, when are you patching it? When are you going to get my systems up and running in a very secure fashion? Because we don't want hackers to come take advantage of this vulnerability and then steal data, because data security is very, very important, right? So in such cases, how will you do it? How will you roll it? I mean, will you sit days and nights to log into each and every EC2 instance and then go upgrade, take the latest version of SSL, OpenSSL and deploy it? No, you have to use something like Systems Manager, with which that's what, if you observed in this video, you can group resources into multiple different buckets, and then you can push software to that centrally, right? Systems Manager will take care of that completely. You don't have to worry about it. Okay, it's a easy to use automation, and with Systems Manager, let me just go. I'm not going to set up the Systems Manager because this itself is a slightly longer topic. So today the focus is more on, I want to introduce you to load balancer, because next week you're going to do a lot of activities on load balancers. Okay, so if you see Systems Manager, so you get resource groups, and then you get some parameter stores where you can store some parameters securely. Okay, and then what you can do is you can get a complete inventory of all your resources, and you can manage the complaints of those of all that inventory. Okay, and you can create a patch baseline and say that, okay, this is where my patching baseliners, and you can just go ahead and add EC2 instances to this patch baseline, and then you can roll out any new patches that come to your EC2 instance through the systems manager. Okay, so that way, and then you can also, there's something called documents where you can build some documents. There are some standard documents that are available using like Ansible. Again, Ansible is another tool. It's a DevOps tool which is used to automate. Okay. Yes, if you see, this is one SSM. It's called SSM, Systems Manager. It's one SSM document which installs patches, scans for or installs patches from a patch baseline. Yeah, it's again represented as JSON. Okay, so that's basically the systems manager. Cost and usage report you've seen. You can go to the cost explorer to understand how much bill that you're getting and things like that. Cost explorer and X-ray. I think I spoke about X-ray. You can just ignore about AWS distro, right? So these are some of the services that you should know, right? I mean, these are things that you should know about it, right? And it is not it's not necessary that you get a hands-on with each and every service. It's okay. It's not needed, but at least now an interviewer asks you, how do you manage the patch lifecycle on AWS at scale, right? For say 5,000 EC2 instances, how will you roll out patches? Immediately you can say that we'll use Systems Manager to roll out the patches in a secure and centralized way. Okay. Okay. All right. So now what I'm going to do is I'm just going to go to load balancers. Load balancers are a very, very important topic. I don't want all of you to pay good attention to the load balancers. Yeah. So it's actually under EC2 only, right? So we're I'm just searching the where do I find the um, okay, let me just Google for it. AWS ELB documentation. Yeah, it's more simpler. Okay. Okay. So okay, so now let me just go back to my okay. Let's go back to our whiteboarding. Okay, I've got a let me bring original diagram back. Okay, let's bring this diagram. Elastic load balancers. It's called elastic load balancers. Okay. All right. So now I have an account. I have VPC. I've got multiple subnets, multiple availability zones, right? I've got EC2 instances, right? So now let's assume I've got two availability zones, right? So where I have my web servers running, right? So these are my web servers, right? So EC2 web server 1, EC2 web server 2, right? I'm running like two web servers, right? For the sake of high availability, right? Because if one web server goes down, at least I have another web server to receive the traffic and serve the content, correct? And that way, I'm ensuring that, my service that the website that I'm building or the service that I'm providing, this does not go down, right? I'm basically minimizing the outages on my service, on my application, right? So that's the reason you always deploy components in multiple availability zones. And you ensure that if one availability zone goes down, the other availability zone is still available because the other AZ is a separate geographical location, which is like spread with the distance of 100 kilometers. If there is a flood in AZ1, you still have AZ2 available to serve your content from. But how do you distribute the traffic between these two web servers, web server 1 and web server 2, right? And how do you ensure that there's somebody who can monitor, who can mediate between web server 1 and web server 2, and they're able to send the traffic and distribute the traffic equally between web server 1 and web server 2, right? That is where you see load balancers play a major role. Load balancers are nothing but, it's like a task master, right? You have, like, for example, you have okay, you have an event. Okay, let's assume there's a you have a college reunion or school reunion event that's happening, right? It's happening at a mass scale. Obviously there will be a few people who will coordinate this event, right? And eventually on the day of event or the previous day when the arrangements are being made, these coordinators will be the central piece, correct? Where they will manage, what all activities are there, what all activities are pending, and people who are volunteering will basically will follow the instructions given by the coordinators, correct? So now coordinators will distribute the task between all the volunteers, and then they'll say that, okay, hey, you go ahead and take care of this, right? And then they will also say that, you go and, buy something, or you go and do this activity, right? So that way, the coordinators do a distribution of work among multiple people, right? Because if everything has to be done by one single person, that's not humanly possible, correct? So the work has to be equally distributed across multiple different people, right? So from that perspective, load balancers are similar. Load balancing is a very similar thing where you have a load balancer, and load balancer, okay, receives the traffic, and it is load balancer which will send the traffic to the subsequent nodes, right? Now all of these nodes are registered with the load balancer. Okay, so now the load balancer receives the traffic, and load balancer sends that traffic to the targets. These are called targets, right? It sends the request to these targets, and then it will receive it back and give it back to the client. So this guy is a centralized guy, and the load balancer service itself is a highly available service. Okay, because a load balancer spans across multiple availability zones and multiple subnets. Okay, it's not that load balancer can sit only within one subnet or one availability zone, right? Unlike your EC2 instance, where in your EC2 instance, you have an EC2 instance sitting only in one availability zone. If this AZ goes down, this EC2 also goes along with it. But load balancer is not like that. A load balancer spans across multiple availability zones, multiple subnets. That way, if this subnet or if this availability zone goes down, load balancer doesn't go down. Load balancer is still active. It can still send the traffic to the second web server node. Okay, so that's basically the job of a load balancer. Now again, load balancer has got several algorithms that it uses. One common algorithm that load balancer uses is called a round robin. Okay, what is a round robin? Like, again, I'll take the example of the college reunion coordinator, and he has got about 10 people registered with him, right? So now whenever he gets a work, he gives it to the person immediately who is available. Okay. The next task comes, he will give it to the next person. Third task comes, he gives it to the third person. Fourth task comes, he gives it to the fourth person. Like that, he distributes, he ensures that everybody gets a task. And not a single guy is overloaded with so much of tasks, right? So that he breaks down, right? So that way, it is the job of the coordinator to ensure that everybody is healthy and nobody is overloaded and nobody is also less loaded, right? I mean, it's not that somebody is sitting idle and chit chatting, correct? So that is the job of a coordinator. In this case, load balancer also does the same thing. If say there are two nodes registered with the load balancer, it ensures that it sends the first request to node 1, second request to node 2, third request to node 1, fourth request to node 2, fifth to 1, sixth to 2. Like that, it keeps alternating between node 1 and node 2. Every other request that comes to it comes to load balancer. That is called uh, that's called an algorithm. That's called the round robin algorithm. Okay, that's a basic of what a load balancing is, right? In fact, load balancing is very, very important. You have to understand load balancing, and because load balancing is a very, very crucial important topic. Okay, so elastic load balancing automatically distributes your incoming traffic across multiple targets. These are the targets such as EC2 instances, containers, and IP addresses in one or more availability zones. It monitors the health of its registered. Okay, so now what it also does is, say for example, this AZ goes down. Okay, uh, then as part of that AZ failure, this EC2 instance also goes down, right? So now what the load balancer does is, load balancer constantly monitors the health of all the targets that it has registered with. Okay, so now immediately load balancer will get to know that, okay, EC2 web server 1 has gone down, and it should no longer send the request to EC2 web server 1, because if it sends the request to EC2 web server 1, that will get lost because web server 1 guy is not in a healthy state. Okay, like coordinator, one guy falls sick, and then coordinator can't assign work to that guy, right? Because he'll not be able to take that work any longer because he's sick or he's injured. Similarly, right? So out here, so that's where it knows the health of each and every EC2 instance, and it gets a heartbeat from EC2 instance uh, through health checks, and then it will know the health of, and then it will not send the traffic to that particular target. Yeah, and routes only to the healthy target. Elastic load balancing scales your load balancer incoming traffic changes over time. So now in this case, this elastic load balancer that you have can scale. Okay, if the traffic is coming high, it can automatically scale, and it can automatically scale down also. It can scale up and scale down according to the kind of traffic that it is receiving. Okay, a load balancer distributes workloads across multiple compute resources, such as virtual servers. Using a load balancer increases the availability and fault tolerance of your applications. You can add and remove compute resources from your load balancer as your needs change without disrupting. If you want, you can add more nodes to this. Nothing is going to change from your application perspective, right? I mean, it's not going to impact your application. Now, you can also remove this. So when you remove the one node from the load balancer, it will first drain that. It will wait for all the outstanding requests to be completed by this guy, and then it will drain it, and then it will remove it from the load balancer. It's like one guy in the reunion function says that, okay, I'm done. I'm like, I want to take rest. Okay, then the coordinator will say, okay, fine, what all activities that you're currently doing, you finish it, and then after that, I'm not going to give you any more activities, so you can go and take rest. So such way, in such a way, you're also, if you deregister a web server or an application server from the load balancer, it will wait for all the outstanding requests to be completed, and then it'll not send new requests to this guy. Okay, again, you can use any of these to configure load balancers like management console, CLI. Okay. Okay, so now let me just go how load balancing works. So there are 4 types of load balancers that are available in AWS. Okay, the product name is called Elastic Load Balancer, but within ELB, there are four different types of load balancers. One is called application load balancers, which is used for mainly for the application layer, right? Layer 7. So what are the 7 layers of TCP/IP? Can somebody unmute and answer those 7 layers? Go ahead. Somebody was unmuting. Physical, data link,
Sir, physical,
network.
data link, network, transport, session, present, and application layer.
Yeah, okay, excellent. Very good. So those are the 7 layers of TCP/IP, right? So now if you see, application load balancer is at layer 7. Okay, it is at an application layer where it can only work on HTTP and HTTPS protocols, because HTTP, HTTPS protocols are layer 7 protocols, right? Whereas network load balancer is at, what is network layer? Layer 4. Sorry, layer 3.
Yes, sir.
Okay,
Routers
layer
and
3 is network. Yeah, layer 3 is network. Okay. Okay, so now network load balancer acts at the layer. So when you say network, I mean, it doesn't act at a physical layer, but it acts at the transport layer, at a TCP/IP layer, which is layer 4, basically. At a T is transport is fourth layer, right? Physical data link, network, transport. So transport is layer 4. So now network load balancer acts at a layer 4, where it acts at a TCP/IP layer. It does not act at an application layer. Okay, it acts at a much lower level. Okay, and then there's something called newly, which was introduced, called gateway. Ignore that for now, okay, because it was just launched last week, so you don't have to really worry about too much about it. Then classic load balancer was a very old style load balancer, which AWS will deprecate in some time, so you don't have to worry about classic load balancer. The two load balancers that you have to learn are application load balancers, which is called ALB, and network load balancer, which is called NLB. Okay, so just give me a second, I'll just be back. So that's so application load balancer is at layer 7, network load balancer is at the layer 4. Okay, so these are the two load balancers that you need to understand. Okay, so now, as I said, if you see, you have a availability zone A, availability zone B, and you have load balancers which is common for both the availability zones. So availability zone A has got 2 instances, availability zone B has got maybe 8 EC2 instances, right? So what it does is it equally routes the traffic to both the zones. These are some of the concepts that you need to understand. But yeah, I more importantly, what I want to kind of look at is the routing algorithm. The load balancer is a very, very involved topic. Okay. But I don't know how many of you have actually worked with load balancers in the past, or any load balancer, not just AWS load balancer. Can somebody raise your hands if you have done it? Okay, 832 you have done it. Okay, good. So you've worked with AWS load balancers or something else?
AWS load balances, sir. Actually, I have run HTTP applications here.
Okay. Okay, so if you see, there are a few algorithms that it uses. In fact, I'll show you when I give a demo of it. So if you see, the default routing algorithm is round robin, as I said, right? Routing is performed independently for each target group, even when a target is registered with multiple target groups. Okay, I'll explain you what a target group and how do you register targets and things like that. But for now, all of you have to understand that uh, an ELB, which is basically an ALB or NLB, right? Application load balancer or network load balancer, acts as a coordinator which distributes the workload across multiple different EC2 instances, which are multiple different targets. Okay, again, don't think that load balancers can only be used with EC2 instances. It can be used with containers, right? It can be used with your microservices architecture, right? It can be used with your Lambda functions, right? And you can also use your AWS load balancer to load balance your on-premise servers. It can be an IP address based, where you just register that IP address to a load balancer. It will be able to load balance your on-premise web servers or application servers. Okay, so that's predominantly um, uh, your load balancer functionality. Okay, so now let's get started. I'm just going to go to EC2. Right, your load balancers you'll find it on EC2. Let's do a small lab. Okay, so if you see here, you'll get load balancers on the EC2's main page. Click on load balancers. I don't have any load balancers right now. Okay, but before that, let me go to my instances. Okay, I'm actually going to just terminate these. I don't want these instances anymore. Okay, I'm being a bit tardy with cleaning up my EC2 instances, but you don't have to be like that. Okay, you have to clean it up then and there. Okay, don't imbibe my example. Bad example. Okay, you'll have to clean it up then and there after your lab session ends. Okay. Okay, I'm just going to launch an EC2 instance. Okay, I'm going to do select this. Yeah, I'll just go next, configure instance details. I'll provision 2 instances. Okay, I'll provision one by one. I'll just provision it in subnet 1. Okay, so now this time what I'm going to do is I'm actually not okay, I can provision this in the public subnet, and then I'll also provision this in the private subnet and show you. Okay, so I'm just going to provision this in the public subnet, and what I'm going to do is let me just click on next. Yeah, next is add storage, but before that, let me bring my bootstrap script. Okay, just bring my bootstrap script. Here's my bootstrap script. Yeah, this is my bootstrap script. Oh no, not this. Material module 1, day 1. When did we learn the bootstrapping? 8th day. We learned bootstrapping on one day. Which day was that? Can somebody tell me, please? Because that script, I just need that script, as I don't want to write that once again. Okay, let me just check. When did we do bootstrapping? Yeah, on 4th November. Okay, got it. Okay, 4th November. Okay, did I not give you that small code for bootstrapping? Okay, no worries. Let's write it. Okay, or let's just go ahead and install that directly. Okay, I'm just going to provision an EC2 instance. I'm just going to say web server one, sorry, name as web server one. Next, configure security group. Yeah, I'll just use my existing security group, which is this. Yeah, review and launch, RPL Mumbai Lab. Yeah, launch instance. That's my EC2 instance one. Let me launch my EC2 instance two, which is this. Configure EC2 instance details. Yeah, the same subnet. I'll just add, yeah, I'll just add a tag. I'll just say name web server two, security group, previous, select public SSH all, launch, select Mumbai Lab, launch instances. Just go view instances. It's being provisioned. Okay, so let me first log into my first EC2 instance. This one, just putty. Okay, just connected to this. Sudo su yum update -y to just update it. Come back. I'll grab the second IP address. Come back. Okay, it's done. Okay, I'll just so yum install httpd. Yeah, so install httpd. That's done. Okay, so now let me just go back cd /var/www html. Okay, just say vi index.html. I'm just going to say html hello h1 rpl champs /html, sorry, /h1. I'm going to put h2 saying this is being served from web server 1 /h2/html. Save this. Okay, perfect. So I'll just say yeah, so it's done. Okay, so let me just create a new session. EC2 user @ control V. SSH auth browse your mobile app appearance change 20 session. I'll just save this as a web server too. Yes, web server 2 sudo su yum update -y. Okay, yum install httpd-y cd/var www html vi index.html. Just going to copy this as it is. Come back here, put insert mode, paste it. But instead of this, what I'm going to do is to say that this was being served from web server 2. Instead of web server 1, I'm just changing it to web server 2. Save it. Yeah. Service httpd start. Okay, cool. It started. Okay, on both the EC2 instances, it is started. So now what I'm going to do is I'm just going to browse that. I'll just open a new browser window. I'll just say this. Yeah, this is from web server. The first one is from web server. I'll pick up the second one. Second IP address. Yeah, this is from web server 2, right? Hello, IPL chance. This is being served from web server 2. This is being served from web server 1. Now, I have two EC2 instances which are running the same code. Okay, similar code, but I'm just going to create a load balancer in front of them. Right now, I'm just using the web server's IP address directly to access it. Okay, but I don't want to access it directly through the web server's IP address, right? Because the moment I access it directly, it'll only go here, right? I mean, it'll directly go to the web server one. You can't use your ask your end users to directly hit the web server, right? You need some common location where they go, and that distributes the load, right? You don't want your web users to distribute the load by themselves. You need one coordinator who can distribute the load. Okay, so that's where we will now create a new load balancer. I'm just going to go to load balancers. I'm going to create a new load balancer. Okay, and then I'm going to create a application load balancer, right? You will see these three options here. This is like going to be deprecated anytime. So don't use classic load balancer unless you need it. So use ALV or NLV. I'm going to create a load balancer. I'm going to give a name to it. I'll say my RTL lab ALB. That's the name that I'm giving. You want it to be an internet facing load balancer or an internal load balancer, right? I mean, that's an important thing, right? You want this load balancer to be having facing internet or just being internal. Okay, so that way, if you make it internet facing, it will get a public IP address to it. If you make it internal facing, it will only receive the IP address from within the VPC. You can also do that. You don't want certain applications to be available on the internet. It's an internal application. It's just an internal facing application, intranet application. So you can use a normal intranet load balancer, and then you can build. So in that case, you will select internal, where it will get only the private IP address. It won't get a public IP address. But in this case, we need a public IP address. So I'm just going for an internet facing load balancer. Select IPv4 or dual stack. If your application supports like IPv6, select dual stack, or else leave it. And okay, listener, right? What is the listener? The listener is load balancer will receive the request, correct? Now load balancer should receive the request on port 80 or port 443, because that is where the HTTP protocol is running, correct? So in the case of application load balancer, it can only be HTTP or HTTPS. It can't be a TCP port. It can either be port 80 or port 443. No other ports. Okay, so HTTP or HTTPS. So that's the thing that where you go and select HTTP. right? And then you have to select the VPC where your load balancer should reside, because this is my VPC, right? My VPC. I'll put my load balancer in my VPC, and then you have to select which all availability zones that the load balancer has to be available. Because as I said, a load balancer is not just a resource which is only with one availability zone, right? It can span multiple availability zones. Yeah, so that way you have to say, I want my load balancer to be available in AZ1 and AZ2, right? I'll just go and select AZ1 and AZ2, and you can select which subnet your load balancer interfaces should be available. Okay, so eventually what happens is when AWS provisions the load balancer for you, it provisions the respective compute required for the load balancer in all these availability zones that you select, AZ1 and AZ2. And within those subnets, it'll provision a network interface so that the load balancer network interface is available in both the availability zones and both the subnets. So you have to select which subnet you want it to be provisioned. I'll say subnet 1 and subnet 2. Okay. Right now, I don't have any resources in subnet 2, right? I mean, all my uh, resources are in subnet 1 only. In fact, it's here only. In this particular lab, it's here only. I've not provisioned it in subnet 2 as yet. Okay, because both the EC2 instances are public facing EC2 instances, right? This is the public subnet that I have, right? So I don't have anything in subnet 2. In fact, I can ignore subnet 2. If I don't want to select subnet 2, I'll just ignore subnet 2. Okay, and then I'll just say next, configure security settings. Okay, at least two should be selected. Okay, fine. At least you should have two subnets, because your load balancer itself is a highly available resource, right? So if you don't select two availability zones, then if one AZ goes down, your load balancer also goes down along with it. So that's why AWS mandates you to select two availability zones and two different subnets to be available. Okay. Next, configure security groups. Okay, load balancer also has got a security group. Okay, so where like EC2 instances, you have to select a security group for a load balancer. Okay, so where you select that our public SSH access all security group, which has port 80 open to the world, correct? So your port 80 should be open to the world for your load balancer, because the load balancer is the one which is going to accept the request and then forward the request to web servers. So your port 80 should be open for load balancer to the world, like how you did it for web servers. So in this case, you can remove the port 80,000 on the ingress rules on web servers. You don't need that anymore, because you have your load balancer sitting in the DMZ, and which is able to receive the request and send it to your nodes. If you want, you can remove that. We'll do that later in the next lab exercise. Next, configure routing. Okay, so now here is something called target groups that you have to create. Okay, so now you've created the you've defined the load balancer, but you have to add these two web servers to the load balancer. So that is what it's called target groups. So I will just say my RPL LB lab target group 1. I'll just say target group 1, and you can select either an instance, where if you select an instance, you will get all EC2 instances listed, or it can be an IP address also. If it is routable, if you're able to ping the IP address, and if there is a network connectivity available between your load balancer and any IP, you can also send it to any IP address. Or it can be a Lambda function as well. Lambda function is something that we're going to cover next week. For now, just stay put. I'll select instance, and the protocol of my target group is going to be HTTP protocol, port 80. Okay, and which version of protocol that I want to use? I want to just use HTTP 1.1 or 2. And then health check, I want to do health check on HTTP, right? And path is slash. Now, what does that mean? So now this is the slash, right? I'm actually serving index.html on the path slash, which is this nothing, but you can also leave it like this, which is the root of the web server, which is slash. The root of the web server, I'm serving index.html. So what it will do is it will keep pinging this index.html. The moment it returns 200, okay, let's see what the code that it returns. Okay, I'm just going to refresh it. If you see, it returns 200, correct? So it returns a 200 code. The moment it returns a 200 HTTP code, then which means that your web server is up and running. So that's the health check that it does. Okay, so that's what the protocol is HTTP, path is / on the target. That is the health check settings. And you can also do advanced health check settings where you can say that you do your health check on the traffic port itself, which is port 80 HTTP, and healthy threshold is 5, unhealthy threshold is 2. Right? If the web server goes down, and for 2 times, if the load balancer receives that the web server is not able to return status code of 200, then it will call it as unhealthy and it will not send any request to that. And timeout is 5 seconds. Okay, the timeout is like if it doesn't receive the request like for 5 seconds, then it will time it out. It will time out that health check web request. And interval is it will do a health check every 30 seconds. So now in this case, I'll make it 5 seconds. I'll make the timeout as 2 seconds, so that we can get the results immediately. And success code is I'm expecting 200 as the success code. Okay, 200 is success, right? In HTTP, 200 is a success request code coming from the website. Okay, so now this is done. I'll just go next, register targets. Okay, so now here I'll see all the targets, all the EC2 instances that are there. I'm going to select web server 1 and web server 2, and I'm going to add to registered on port 80. Okay, I'll just say add to registered. Yeah, this is now added to the registered targets. I'll just say next review. I'll just review everything. I'll just say create. Yeah, so it's created the load balancer, but it will take some few minutes to provision the underlying infrastructure for that. And then let me go to the target groups. It would have created a target group also. If you see, it created a my RPL target group 1, lab target group 1. I'll just select the target group. And if you see here, this is the health check settings. Health check is happening on port protocol HTTP on the path /, which is just checking whether the index.html is returning status code 200 or not. It can be a success page, right? It can be anything. I'll show you in the next lab. And then you have a 5 consecutive health check successes. 2 consecutive health check failures will call it as unhealthy. Timeout is 2 seconds. Interval is 5 seconds. Success code that it will expect is 200. And the algorithm that I'm using is round robin algorithm. I can edit the algorithm also out here. I can use a released outstanding request algorithm. And I'll also use select stickiness. Stickiness is nothing but, if you're using sessions, if one web server 1 is having the user session, any request that comes from that user always goes to web server 1. Okay, so that way, you don't have to maintain the user sessions in multiple different web servers, because assume a user logs in and then his session is maintained in web server 1. Next time when he's sending a request, if the request goes to web server 2, again the user will be presented with a login page, which will impact the user experience, correct? So from that perspective, you have to maintain stickiness so that load balancer knows that for so and so user request, it has to always send the request to the web server where his session is available. So just give it 30 minutes. Selected it, and if you go to the targets, target registration is in progress. Okay, it was actually showing it in progress. It just became healthy because it is able to listen on port 80 on both web server 1 and web server 2, because both web server 1 and web server 2 port 80 is returning some content, correct? It's returning a 200 success code, so it's healthy. Okay, so now let me go back to my load balancer. You have to wait for this to turn healthy. So once it is healthy, the load balancer is working fine. So now your load balancer is active. So now how do you access the load balancer? If you come down, you will see a DNS name for the load balancer. You have to copy this DNS endpoint of the load balancer. Copy this, come back, and then open a new browser window and browse that. Hit enter. Yeah, so If you see hello RPL champs, this is being served from web server 2. If I do a second request, okay, now if you see stickiness is enabled. So that's why it's always going to my second load balancer, second node. Now what I'll do is I'll just go ahead and disable my stickiness. I'll just disable my stickiness, wait for some time. Okay, I'll just refresh it. You will see that, it'll, alternatively, it'll go to, let me open in another browser so that it considers a new request. Open a new incognito window. New private window. Yeah. So now if you see, it's going to web server 1, web server 2. Next time I do, yeah, now it's web server 2, web server 1, 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 web server 2. So it will keep sending alternative requests, right? Now, next time I refresh, it will go to web server 1. Next time, if I refresh, it will go to web server 2. If I refresh web server 1, if I refresh web server 2. So that's the round robin algorithm. Okay, because I've configured a round robin algorithm. So it is basically sending the request in an alternating fashion between my web server 1 and web server 2. Okay, so that's what it does, provided you don't have the stickiness. If you have stickiness enabled, then right now stickiness is disabled. But if you enable stickiness, I'm going to enable stickiness. I'm going to say probably, yeah, I'll just say 5 minutes is my stickiness duration. So if I enable stickiness, so the first request that I'm going to make probably might go to web server 1. Probably the second request also, you see, let the stickiness get uh, applied, right? You will see that it is not changing. See, now it is applied. It is always going to web server 2. See, it's not going to web server 1 at all, because my user session is with web server 2. Okay, so it's always going to web server 2. It will not go to web server 1 at all. But the moment I come back, I disable the stickiness and give it a few seconds for the changes to take effect. Yes, it's disabled. Let me just refresh it now. Yeah, so now if you see, it is disabled. It is going to web server 1, web server 2, web server 1, web server 2, web server 1, web server 2. Okay, so that's pretty cool. It is correct. Okay, so now let's do one thing. I'm going to strip off everything. I'm going to delete my target groups. Just delete it. Okay, I'm just going to go to my web server. Okay, so now there's one more thing that I want to show you in application load balancer before I delete it. Okay, so let me go ahead and delete this. I'll come back, do a fresh setup and show you one more thing. Rules are very important. I want to show you how the rules work. Let's just delete this target group. I'll just delete this target group. Your target group is deleted. I have a load balancer. This is my load balancer. Load balancer has no listeners, and there's no target group. Okay, let the load balancer remain as it is. But what I'm going to do is I'm going to go to EC2 instances. I'm going to deprovision those EC2 instances. Right now, these EC2 instances are on public subnet, right? Where I have public IP address associated with the EC2 instances. Okay, but what I want to do is I don't want my EC2 instances to be in a public subnet. Okay, only my load balancer has to be in the public subnet. Right now, if you see, if you go back to our design, my load balancer is in public subnet and private subnet, but my load balancer is publicly facing load balancer, but my EC2 instances are also on public subnet, which is subnet 1. Okay, so now I want to change that behavior a bit. What I'm going to do is I'm going to terminate these two instances. Okay, just terminate this EC2 instances. It's all gone. Okay, so now let me just come back to my diagram. What I'm going to do is I'm going to move these EC2 instances from a public subnet into a private subnet. Okay, let it be in a private subnet. I don't want them to be in the public subnet. But whereas I want my load balancer to be in publicly available, right? And I want my load balancer to send the request to my EC2 instances. I don't want my EC2 instances to be exposed directly to the internet. I want only my load balancer to be exposed to the internet. Okay. So now what I'm going to do is I'm going to create two EC2 instances in private subnet. Okay. So let me just go. I'll just launch an instance. This time I definitely have to use my bootstrap. Okay. So now I'll select my VPC, but this time I'm going to select AP South 1B subnet 2, which is going to my public private subnet, which is subnet 2. Okay, and I will not get a public IP, so I won't be able to log into the DC2 instance. So I better use my bootstrap script to create my EC2 instances, to install all the software in the EC2 instances. Once again, I'm just searching for the bootstrap script.
Sir, I have sent you in the chat, sir.
You have sent me in the chat. Okay, thank you so much.
Okay.
Kept it handy. Yeah, thank you so much. Okay, I'm just going to go here. I'll just copy paste this Z004. Thank you so much. I'll paste the bootstrap script given by Z004. Yeah, sudo yum update, yum install loy httpd ssctl start enable cd/var www.html sudo su. Yeah, so yeah, I'm just going to slightly modify this h1. I'll also add a h2. Yeah, I'll just add a h2. I'll just say this is being served by web server 1. I'll just make this h2. Yeah, greater than index.html sudo service httpd start. Okay, perfect. Okay, I'll just copy this. Next, add storage. Yeah, this is fine. This is fine. Next tags. I'm just going to say name web server 1. Say private web server 1. The public web server. Configure security groups. You can choose this itself. Of course, you won't be able to teach. Yeah, you won't be able to SSH into that. Anyways, that's fine. But yeah, so here, okay, let me do one thing. I'll just create a new security group. What I'm going to do is to create a security group which will allow the traffic to go only from the load balancer. So in this case, I have a load balancer security group. I want the traffic to only go from load balancer to the web server. Okay, let me say I'll create a web server SG, web server SG. I don't want SSH. I'll only use HTTP. So I want my HTTP request to go only from the load balancer security group, which is, I'll just say right now the load balancer security group is, I've selected this one as the load balancer security group. So my source is to only go from, this is called self-referential security groups, right? My traffic can only go from load balancers to my web servers. So my load balancer security group is this. I've just selected that. Review on launch. Let's just say launch. Say launch instances. Okay, so let it launch the instance. I'll again launch another EC2 instance. Okay, t2.micro. South 1B disable. I'll just paste the thing. I'll just make this as web server 2. Rest of it is same. Next, add the tag name private web server 2, private web server 2. Next, configure security group. I'll just use the same security group of web server security group, which will allow traffic only to come from load balancer. Next, continue. That's okay. Launch. I acknowledge RPL Mumbai lab is available with me. Launch instances. Okay. Okay. So let the EC2 instances come up. Yeah. So both the EC2 instances are running. Yeah. So if you see, private web server EC2 instances are running. It's filtered by private web server. Yeah. This is running. Okay. And if you select one of those instances, you will not have a public IP address. So you'll only have a private IP address. And you won't be able to access it publicly, right? I mean, if you go within that, I mean, you'll be able to access, if you say 10.0.2.147, if I log into my public EC2 instance, I still won't be able to access because I've not given the security group. That's okay. So our intent is to register these two EC2 instances in our load balancer. So let me go back to my load balancer. I'll create a new target group. I'll use instances as the target group. I'll just say my RPL lab. I'll say TG target group 2. HTTP is port 80. VPC is, this is the VPC. Okay, our protocol version is HTTP 1. Health check is this. Advanced health check, I'll just make it as interval as 5. I'll make interval as 20 seconds so that I show you. I'll just say next. And then I'm going to register these two EC2 instances to that. I'll just register these two EC2 instances, include as pending below. Okay, and I'll just say create target group. Okay, so target group is being created. Let me go to the targets. Okay, first you will see that it is currently unused, but let's just wait for the target group to come. Okay, it'll become unused till you register it in the load balancer. So you have to go to the load balancer. You have to go to listeners, add a listener. Okay, and the listener that you want is HTTP port 80. Okay, and what is the action that you want to do? You want to, anything that comes on port 80, you want to actually forward the traffic to so and so target group, which is this target group. Okay, 100% of the traffic is being distributed to the target group. Anything that comes on port 80 of the load balancer. So now if you see, if I refresh this, this will time out. There's nothing registered here. It will keep spinning and it will give me a timeout at some point in time. Okay, after the timeout, it will just give me page cannot be loaded because it's still spinning. Okay, it's not able to serve the web server properly, right? So now let me just go here. I'll just add it. What I've done is I've created a listener on port 80. I'm forwarding the traffic to target group 2. I'll just click on save. So it successfully created a listener. Okay, so now if I go to target group and say that go to targets, it will move to initial. From unused, it is now changing the status to initial. It is initializing this target group, these targets into the target group. It will time out. This will time out shortly. Okay, so let's just keep refreshing. You will see that the target registration is in progress. That is the status that it is giving. Yeah, you see target registration is in progress. Let me refresh this. Okay, so the health checks have failed. Let's just wait. Okay, so the health checks have failed. So now we have to troubleshoot why the health checks failed. Okay, so now let's see what is the security group for this EC2 instances. Security group for the EC2 instances is allowing port 80 from the source security group. This is the source security group. So let's review that security group. Okay, AS6, this is the security group. Public SSH access all. So now public SSH, public SSH access all has got bound rules as port 80 from all of these, and outbound is you can access anything, right? So it should ideally work. It shouldn't fail. Let's see. Okay, so now let's just go and look at the health checks. Okay, health check is HTTP on slash path, traffic port, 5 consecutive health checks, 2 consecutive health checks failures. You are expecting a success score of 200. Okay, so now let's troubleshoot what is wrong with my EC2 instance. Okay, so now what I have to do is I have to go modify the security group of the EC2 instance to allow bound rules SSH to come from 0000. Okay, it's already allowing SSH from 0000, right? Okay, fine. So what I'm going to do is I'm going to grab my public EC2 instance first. And then from public EC2 instance, I'm going to SSH into the private EC2 instance. So this is my public EC2 instance. I'll just grab this, go to my putty. These are gone. I'll just close this. Close windows. I'll just open up putty. EC2. Do I have public EC2 instance available? Yeah, okay, it's there. Cool. From here, I'm going to SSH into SSH minus I RPL Mumbai dot lab.pem EC2 user at the rate. What is the private IP address of my private EC2 instance?
Ray,
Private web server 1.
Vigyan.
Sorry, somebody is on unmute. Please go on mute. Okay, 10.02.147 and 10.02.29, right? Okay, I'll just say 10.02.147. Okay, inbound, I have to change this inbound. Allow traffic from 00, edit inbound rules, add a rule, SSH 0000, save rules. Okay. Yeah. Okay, so now this is there. So now let's see whether the service is running or not. Service sudo su service httpd status. Okay. Okay, see, basically the service is not running. That is the problem. You know why? Okay, the bootstrap script that we put, okay, which I got from Z004, since it is in a private subnet, it didn't have internet access. Okay, so we were not able to actually install HTTPD in the private subnet. So for that, what you need to do, if you need internet access on a private subnet, what do you have to do?
NAT
NAT
gateway.
gateways.
NAT gateway, excellent. Okay, you need a NAT gateway or a NAT instance to be available so that you will be able to start the web server. Okay, so now what I'm going to do is I'm not going to create a NAT gateway. Okay, so let's do a little more adventurous stuff. Okay, I'm going to just go delete those EC2 instances. I'm going to take an AMI. Okay, I'll use an AMI to bring up my web servers in the private subnet. Okay, I'll just say actions instance state terminate these two instances. Okay, so now what I'm going to do is I'm just going to take an AMI launch instances, select configure instance details. This time I'll provision it in the private subnet, public subnet. I'll just grab the bootstrap script, user data. I'll just put it here. Yeah. We'll change it later. Once we log in and we can change it out there. Okay. Just say add storage, general purpose, tags, mega tag, web server template. I'm giving the security group, public SSH access, review launch, use RPL mobile app, launch instances. Okay. If the instance get launched, we'll check if it's working fine, and then we'll take an AMI of it and spin that AMI at the private subnet so that we don't have to install the software. Okay, it's coming up. Let's grab the IP address of it. Come back here. See, it was throwing a bad gateway. Let's come back. Let's paste it. See if it's coming up. Okay, let's give it some more time. Just give it a minute, and then let's take an AMI of it and use that AMI to spin two private EC2 instances of web server. Yeah. Okay, so it's come, right? Okay, it's come up now. So now what I'm going to do is let it finish the initialization. Once it finishes the initialization, let it finish this, taking slightly longer. Then we'll take a AMI of this. Okay, so a template is running. So I'm just going to take actions, image and template. I'll just say create image. Okay, I'm just going to say call this as web server AMI. Good. Just say enable no reboot. Yeah, just create an image. Okay, so if I go to AMIs, I'll find that AMI. Yeah, let this finish. And then we'll use this image to spin two private EC2 instances in the private subnet. And then we can delete the public web server because I have an image with which I can spin as many instances as I want with the same softwares installed. Yeah, it's gonna take a couple of seconds. I'll just say web server image. This is called a golden image. Okay, these are the terminologies. This is called a golden image where you use this golden image to spin as many images as you want. Okay, it's available. So I'm going to delete this. I don't need this instance anymore. Okay, this one. Just going to terminate this instance. 1 second. Did I copy it from the right one? I'm just going to terminate this instance. Terminate. Okay, so that's gone. So now what I'm going to do is I'm going to go use this AMI to launch an instance, a new instance in private subnet. It's a subnet 2. Okay, next, storage, let it be as it is. I'll just say name private web server 1. Configure security group. I'll use that existing security group of web server SG. Launch. Use this launch. Okay, it's done. just going to go to images, AMIs, launch one more instance in the same subnet 2. Next, add storage, add tags, add a tag name, private web server 2 into the security group. Select an existing security group. Web server SG. So you launch instance. So two servers are coming up. Two private servers are coming up. Yeah, two private web servers are running right now. Yeah, let me just grab this IP address. I'll go to my putty. This is my public. I can just do a curl. Yeah, so curl is actually returning. Okay. So I'm able to access it. I can still, so this is web server 1, but I have to log into web server 2 and change it. What is my web server 2? 1145, correct? So curl. Okay, that is also serving, but I have to change it to web server 2 here. So for that sake, let me actually SSH -I RPL Mumbai Lab. Served from web server 2. I'll just change this content here so that we differentiate between web server 1 and web server 2. Save this. Yeah, that's done. So we are done. Oh, sorry, have to. Service HTTPD restart. Yeah, so it's done. I'll just exit, just go back. Then I'll do a curl. Okay, it's coming from web server 2. Okay, cool. That is done. So now let me just come back. Both the web servers are running now. Okay, I'm going to go to my load balancer. First, I'll go to target groups. Okay, this is the target group that I have created. These two targets, but they're gone. I have to register the new targets. Let me go register these two as the targets here. Private web server. Put as pending below. Register pending targets. So now it's actually going to register. Let's just wait for the registration to complete. You should see that it's healthy. It's turning healthy in a while. Yeah, it's healthy. It's turned healthy, which means that load balancer is able to access your and yeah, let me just grab my load balancer's endpoint. Just come back. Okay, I already have this here. Let me just refresh this. Yeah, see, served from web server 1, served from web server 2. It will keep alternating between web server 1 and web server 2. Okay, the only difference is between the previous lab exercise and now is my EC2 instances are in a private subnet. It's to internet. Only my load balancer is access to internet. Load balancer is the guy who is receiving the request from the end user and it is sending it to the targets. Okay, so that way you can protect your resources so that you don't have to put all your resources in the public subnet. Only your load balancer is in the public domain because it's a publicly facing load balancer. If you see, this is the load balancer which is there in the public and you are accessing the load balancer's DNS name using load balancer using the load balancer's endpoint. Okay, that's on this, and also there are a few other things that you can achieve with ALB. You can create rules, right? I mean, in this I have rules, right? So I can actually go ahead, and it's important that you learn this. You can create more rules here. You can say that I can add a condition where I can say that if the path, okay, so for example, right now it is just root. Okay, now I'm creating a website which has got say /blog or /product1/product2, right? Things like that, right? I want to basically use a path-based rules. I can give a path-based rules here where I can say that / if the blog, if the request is coming with the /blog /anything /star, then you can actually forward it to a different target group. It can be a different set of servers which is actually serving that, and you can send it to a different target group. Okay, so that way you can just go ahead and create these, and then what you can also do is it can be based on the host header also. If the host header is blog.example.com, then forward it to so and so target group. So where it actually, so it does all the layer 7 aspects of it. Looks at the HTTP request, it looks at the header, the host header, it looks at the it looks at the path. It also looks at the query string, right? How many of you know what a query string is? Query string is basically if you see here, this /home, right? Here itself, if you see, if the path is like /ec2/star, then send it to one request. If the path is /s3/star, then send it to another target. So you can do all of that. This is basically a classic example of path. Here in this case it is /ec2, right? This is the host header, whereas this is the /ec2 where it is forwarding it to one particular group. And if it has a certain query string, $region equal to, that is the query string. You can also use query string here, where key is region, value is AP South -1. If it finds a query string like this is called a query string. If it finds a query string like this, it can actually forward that traffic to a particular target group. So all these are possible only in ALB, like application load balancer. These are not possible in an NLB, because NLB is at a layer 4, not a layer 7 load balancer, correct? So all these are like going to be quite interesting, right? I mean, as I said, host header, right? I mean, host header is where if any request is coming with the host header as this, right? You can add this here, then forward it to so and so, right? If the request is coming with a path where path has /ec2/star, here in this case it's /ec2, right? /star, then forward it to a target group. So all this things is possible. It's a very advanced one. You can use this for multiple scenarios, right? Where this is the way forward. Now ALB is being used for load balancing your Lambda requests, API gateways, right, and things like that. Not API gateway, Lambda and containers. If you are building a microservices architecture using containers, you have to use ALB. Okay, this will be a famous interview question, right? They'll ask you, okay, so now I've built a serverless, I've built a containerized web application microservices style architecture. Which load balancer should I use? You should say you should use ALB, application load balancer. Okay, so cool. I mean, so what you can do is you can practice this, right? Whatever I've just said today, load balancers. I'm just going to give you the load balancing documentation, right? But the only thing is that I'm not sure whether its free tier is available or not. So let me check AWS free tier. Is load balancer part of free tier? If not, you don't have to do it. I mean, it's your choice at the end of the day. If you want to practice, you can practice, but you're going to be charged. No, load balancer don't have a free tier. There's a free tier offered on, yes, for new AWS accounts. A free tier for an application load balancer offers 750 hours and 15 LCUs. This new, yeah, it is available. Okay, it's available for a application load balancer. Free tier is available. Okay, you can use it. There's a public documentation that says this, so it is available. So you can use it. So I'll just give you an assignment for today. You can quickly do it. Learn ALB and NLB. Okay, assignment will be on ALB. So for that, delete all of this. Provision an EC2 instance in public subnet itself. You can just do it in public subnet itself, or you can use your existing instance that you have provisioned. Okay, or you can just provision an EC2 instance in a public subnet. I'll say provision two EC2 instances in the public subnet with the below bootstrap script. Courtesy Z004. Yeah. So two. Is to make sure you change it in the second one. Change it to web server 2 in the second DC2 instance. You have to SSH to the DC2 instance and change it. You go to that particular HTML file and change it to, yeah, create a new ALB. Go to load balancers, create a load balancer, create an ALB, give a name, select internet facing, IPv4, leave the rest as it is, come to VPC, select both the subnets. VPC, select both the AZs and subnets. Okay, then click on next, configure security settings. Yeah, configure security groups. Config security groups as create a new security group. In fact, we create a new security group. Create a new SG with one rule 0000/0 HTTP instead of select an HTTP on 80.0.0.0.0 and give a name. not going to do that. I'm just going to leave it as it is. Next, configure routing. Configure routing. Just say new target group. New target group. Give a name. Name is my TG. Yeah, and instance. Leave the rest as it is. Protocol is HTTP, port is HTTP, rest is all as it is. Advanced health check settings, you can just give interval as 30 seconds, that's okay. Leave those as it is. I'll just give a screenshot of this. Register targets, select these two targets and add to registered. Add to registered. Next, review, create. In fact, I'll just insert all those screenshots here in the same order, okay? Okay. Yeah, you just need to follow these steps. Create the load balancer, give a name, internet facing, listeners, leave it as it is. VPC, select your VPC, select both the subnets, then click next and configure security groups. Create a new security group, HTTP 80. Yeah. And then click next, configure routing, create a new target group, give my target group, keep it as HTTP port 80, health checks, keep it default, click next, register targets, select those two targets from the below and add to registered, then you should see it in the registered, then say next and finish. Then your load balancer should be up and running. So once your load balancer is up and running, sixth step is, I'll just put it here itself. Sixth step is take the DNS endpoint of the load balancer of the ALB and browse the website multiple times Okay, here you have to change it. Okay, step 3 is change the yellow highlighted to web server 2 in the second instance. Okay, this portion you have to change it. Then browse the website multiple times. You should see the content served alternatively from web server 1 and 2. Okay, also wait for the health check. Go to target groups, health checks, wait for health check to turn healthy in the target group. Okay, and for your EC2 instance, create up a use a security group for the EC2 instance to allow 80 HTTP port 80 from 0000/0 for now. Okay, we don't have to worry about it. We'll do more elaborate exercise in the next week where we are going to build a complete website where we will restrict the traffic appropriately. But for now, use a security group for the EC2 instances to allow HTTP 80 from 000, so that your load balancer is able to talk to the chip. Okay, cool. And then finally clean it up. Once complete, clean up all the resources. I'm going to do it right now, otherwise I'll keep forgetting. Okay, I'm going to go to EC2 management console. I'll go to EC2 instances. Let me see what all are running. Okay, I have private EC2 instance, private web server, private web server. I'll leave the private EC2 instance, something that I'm going to terminate. Sure, terminate, and then I'm going to stop these two guys. I don't want them to be running now. I'll bring this up again, maybe the next session. I'll just stop this instance. Stop it. Okay, stopped it. So that way, not incurring any additional charges. Go to load balancers. Okay, I'll just go to load balancer. I've created 2 load balancers. I'll just first delete this first load balancer. Delete. Yeah, it's done. This is also just go and delete. Yeah, deleted. I'll just go to target groups, actions, delete my target group. Yeah, done. Okay, so no target group. I'll just select and delete this target group. Yeah, it's all clean. I've cleaned up load balancers, target groups, EC2 instances. Yeah, everything is done. So it's all clean. Okay. All right. So I'm just going to give the assignment document. So please do this. It's very important. ELB and ALB is a very, very important service. You will have to understand that and you'll have to do that. Okay. Yeah, I've given the assignment. So please get into your breakout rooms and do the assignment for today. And I'll see you all on Monday. And Monday, we are going to, it's going to be, as I said, it's going to be, and next 2 weeks are going to be quite important, where you're all going to do a lot of hands-on projects. Okay, 2 major hands-on projects that you're all going to do, which will be a combination of all that you have learned so far, right? And we'll put it in action, which you can demonstrate in a very, very tangible way when you go for interviews or when you go for job selections. You can basically show that as your projects that you have done, and you'll be doing those two projects, one on using EC2 load balancers and auto scaling group to build a complete resilient website using WordPress. That is the first project. The second project will be on serverless architecture using Lambda, API Gateway, DynamoDB, and S3. We'll be building a complete full-fledged web application using serverless architecture, which is going to be week after next week. So please ensure that you all don't skip the next 2 weeks, which is basically the epitome of all that we have learned so far over the last 2 months. So which will give you a lot of good hands-on experience and hands-on knowledge. And yeah, it'll be a good fun experience over the next couple of weeks. And we'll also conduct a few quiz in the next week and week after next week. Okay, all right. So you can go to your respective breakout rooms and start doing these hands-on exercises. Okay, thank you so much. I'll see you all on Monday.